Hello everyone, welcome to this new video. In this lecture I am going to talk about two topics, mathematical model and especially the ingredients of mathematical model. So in this lecture I am going to talk about especially the ingredients of mathematical model, and I am recommending you to follow the books of Fundamental Methods of Mathematical Economics written by Alpha G. Chiang. So, what is mathematical model? A model is merely a theoretical framework, and there is no inherent reason why it must be mathematical. If the model is mathematical, however, it will usually consist of a set of equations designed to describe the structure of the model. By relating a number of variables to one another in certain ways, these equations give mathematical form to the set of analytical assumptions adopted. Then, through application of the relevant mathematical operations to these equations, we may seek to derive a set of conclusions which logically follow from the assumptions. So, for example, the situation of market equilibrium of a commodity can be modeled as, for example, a demand function Q equal to 100 minus 2p, Qs equal to 3p minus 50. And if we set the equilibrium condition, so we get Qt equal to Qs, and from this model we can get the value of P and Q. The star denotes the equilibrium price and equilibrium quantity from this simple mathematical model. Then I am going to talk about ingredients of mathematical model. First one is variables, then constant, parameters, and finally equations and identities. So what does it mean, variable? Very simple definition: a variable is something whose magnitude can change, that is, something that can take on different values. Variables frequently used in economics include price, profit, revenue, national income, consumption, investment, imports, and exports. Since each variable can assume different values, it must be represented by a symbol. For example, we may represent price by P, profit by pi, revenue by R, cost by C, national income by Y, and so forth. When we write P equal to 3 and C, however, we are freezing the variable at a specific value. We can differentiate two types of variables. One is endogenous variable and the second one is exogenous variable. Let's first see the endogenous variable. In simple definition, variable whose solution values we seek from the model are known as endogenous variable. Actually, properly constructed an economic model can be solved to give us the solution values of a certain set of variables, such as the market clearing level of price. From our previous example, we can mention that where P is the endogenous variable, because we have to seek the value of P from the given demand supply equation. That is why P is an endogenous variable. Now turn to our next section, exogenous variables. The the model may contain variables which are assumed to be determined by forces external to the model and whose magnitude are accepted as given data only. Such variables are called exogenous variables. It should be noted that a variable that is endogenous in one model may very well be exogenous to another. তার মানে আমাদের যে ভ্যারিয়েবলটা অলরেডি এন্ডোজিনাস ভ্যারিয়েবল হিসেবে আসতে পারে সেই একই ভ্যারিয়েবলটা আবার কিন্তু এক্সোজিনাস হিসেবেও আসতে পারে। For a better inspection, we can see that in an analysis of market determination of weight price P, for instance, the variable P should definitely be endogenous, but in the framework of a theory of consumer expenditure, P would become exogenous. Let's see how this works. For example, if we want to find the expenditure of a consumer on his or her food products, so let's see the equation CEFP, which indicates here consumer expenditure on food products, PR naught, price of rice, QR indicates here quantity of rice, so PR naught indicates here consumer price of rice, and QR indicates here quantity of rice, plus PP naught indicates here price of potato, and QP naught indicates here quantity of potato, and finally PF naught indicates here price of fruits, QF quantity of fruits. So assuming that there are three consumer items, the total consumer expenditure on food products is the summation of this three expenditure items. So in this case, P are not, that means price of rice, price of potato, price of fruits, are obviously exogenous. But in our previous model, we see that P was a endogenous variable. So same P এক জায়গায় কিন্তু endogenous হতে পারে আর এক জায়গায় কিন্তু exogenous হতে পারে। So depends করবে মডেলে কিভাবে ব্যবহার করা হচ্ছে। Then come to the point constant. A constant is a magnitude that does not change and therefore the antithesis of a variable. For example, in the expression 7p or 0.5r, where 7 and 0.5 are constants. Again, when a constant is joined to a variable, it is often referred to as the coefficient of that variable. And in that example, C equal to CA plus BY, that means a consumption function. C equal to CA plus BY consumption function, where C represents consumption expenditure, CA autonomous consumption plus BY, where Y is income and B is MPC, that means marginal propensity to consume. So if we want to explain this consumption function like this, then see the graph here. It is drawn on the assumption that consumption against its disposable income, or if we indicates national income, then no need to see here the YD. So CA, that part of consumption which does not depend on the level of income, and B measures the level, the consumption level which depends on income. And if we want to get the slope, del C by del Y represents as the slope of this consumption function. We'll discuss about the slope, value of slope, or measuring the slope on our another video. So parameter, the third ingredient of mathematical model is parameter. What is parameter? In very simple term, parameter is unknown constant. That means যখন আমরা কোন একটা কনস্ট্যান্টের ভ্যালু জানি না তখন সেটাকে অ্যাকচুয়ালি বলা হচ্ছে যেটা প্যারামিটার। So a coefficient or constant may be symbolic rather than numerical. যখন numerical হয়ে যাবে তখন সেটা হচ্ছে আমাদের constant, but until we know, it will be a parameter. We can say, for instance, let the symbol a in lieu of a 7p. In our previous example we stated that 7p, but here we stated the symbol a in order to attain a higher level of generality, and until we replace a with any numerical value, it will be a parameter, that means unknown value of that constant, so it's a parameter. The symbol a is a rather peculiar case. It is supposed to represent a given constant, and yet since we have not assigned to it a specific number, it can take any value. In short, it's a constant that is a variable. To identify its special status, we give it a distinct name called parametric constant, or simply parameter. Parametric constants are normally represented by the symbol a, b, c, or their counterparts in Greek letters alpha, beta, gamma, but other symbols you can use. Then come to the point, our final ingredients in a mathematical model is equations and identities. Equation is a statement that the values of two mathematical expressions are equal, indicated by the sign equal. So two mathematical expressions, when expressed in a single term, then it is called an equation. And 5 plus 5 equal to 10 and 3x plus 6 equal to 12, conditionally true for x equal to 2. যদি x এর অন্য কোনো ভ্যালু আমরা এখানে বসাই তাহলে কিন্তু অ্যাকচুয়ালি এটার ইকুয়েশন থাকে না, সো ইন দ্যাট কেস কন্ডিশনালি ট্রু. Again, the equation is true for particular values of the variable. That means our second example, 3x plus 6 equal to 12, এই ইকুয়েশন যদি আমরা দেখি তাহলে তাই বলতে পারি the equation is true for particular values of the variable or variables, but an identity is true for all values, right? Identity is true for all values. So what is identities? একটু ডিটেইলস যদি আমরা দেখার চেষ্টা করি, একটা এক্সাম্পল দিয়ে দেখার চেষ্টা করি. a plus b whole square equal to a square plus 2ab plus b square. খুবই পরিচিত একটি সূত্র, is very known to us all. And another example is pi equal to r minus c, where pi stands for revenue, pi stands for profit, r stands for revenue, and c stands for cost. Let's examine the definition of identities. Using our first example, a plus b whole square equal to a square plus 2ab plus b square. So in this equation, two sides will be equal irrespective of the value we use for a and b. For example, our first example, let a equal to 4 and b equal to 5. Using our first formula, we get here 4 plus 5 whole square, that is 81, and by replacing the value of a and b in a square plus 2ab plus b square, we got also 81, that is two sides are equal, so this satisfies the condition of identities. Again, let a equal to 1 and b equal to 3. In that example, we also find a plus b whole square equal to 16, and the right hand side a square plus 2ab plus b square is also 16. So this is an example of identities. And for our second example, pi equal to r minus c, that means profit equal to revenue minus c, is one type of definitional case. That means revenue থেকে যদি আমি cost বাদ দিই তাহলে সেটা definitely profit indicate করে. So in that case it's also an identity. So an identity is an equation which is always true no matter what the value are substituted. সো এটা আমরা খুব ভালোভাবে দেখতে পাচ্ছি যে আমাদের যদি আইডেন্টিটি হতে হয়, ইকুয়েশনটা যদি আইডেন্টিটি হতে হয়, তাহলে অবশ্যই কি হবে, যে কোনো ভ্যালু আমরা বসাই না কেন বোথ সাইড আমাদের সেম রেজাল্ট দিবে। ভ্যারিয়েবলের আমরা যে ভ্যালুই সাবস্টিটিউট করি না কেন বোথ সাইড আমাদেরকে সেম রেজাল্ট দিবে। বাট ইন কেস অফ ইকুয়েশন, only equation, if it is not an identities, both side may not be same for every values that are we substituted for the variables. Equations in economic applications. Actually in economic applications we may distinguish between three types of equation. First one is definitional equation, the second one is behavioral equation, and finally conditional equation. Let's see about definitional equation. A definitional equation sets up an identity between two alternative expressions that have exactly the same meaning. For such an equation, the identical equality sign read is identically equal to is often employed in place of the regular equal sign, although the latter is also acceptable. As an example, total profit is defined as the excess of total revenue over total cost. We can therefore write from our previous example pi equal to r minus c. That means revenue exceeds over total cost, that is profit. So behavioral equation. A behavioral equation specifies the manner in which a variable, that means dependent variable, behaves in response to a change in other variables, that means independent variables. This may involve either human behavior such as aggregate consumption pattern in relation to national income, or non-human behavior such as how total cost of a firm reacts to output changes. For example, here we see two types of equation. The first equation is consumption function c equal to ca plus by. I have already mentioned earlier c equal to 75 plus 10q, equation number 1, and c equal to 110 plus q square. Both 1 and 2 equation is cost function, where q denotes the quantity of output. Since the two equations have different forms, the two equations 1 and 2 have different forms, the production condition assumed in each is obviously different from the other. In equation 1, the fixed cost, the value of c, is 75 when q equal to 0, and whereas in equation 2 it is 110. The variation in cost is also different. In equation 1, for 1 unit increase in q, there is a constant increase of 10 in c, but in equation 2, as q increases unit after unit, c will increase by progressively larger amounts. Let's see with a table. The first row indicates several levels of output, q equal to 0, 1, 2, 3, 4, 5 and 6, and second row indicates our equation 1, and the third row indicates our equation 2. So when output is 0, then we have a fixed cost 75 according to our equation 1, and when output is 0 according to our equation 2, cost function equation 2, we get that 110 fixed cost. Let's see what is happened if we increase our production. That means 1, 2, 3, 4, 5, 6. What will happen in both of this cost function? According to equation 1, we can see that there is a continuous increase in total cost, which is constant amount, that is 10 units, 75, 85, 95, 105, constant increase in cost. But in case of second equation, there is no inherent tendency to being constant. It is changes 110, 111, 114, 119, so it is increasing with the level of production. So in that case, the cost equation shows us that the first one, where there is a constant increase in the level of cost, but in case of equation 2, there is a rising trend of increasing cost with the level of output. And finally, we try to explain conditional equation. A conditional equation states a requirement to be satisfied. For example, a model involving the notion of equilibrium, we must set up an equilibrium condition which describes the prerequisite for the attainment of the equilibrium. Two of the most familiar equilibrium conditions in economics are QD equal to QS, that means quantity demand equal to quantity supply, that is market equilibrium condition, and the another one is S equal to I, intended saving equal to intended investments, that means saving investments balance equation. So still we have covering our three types of equations, which is an ingredients of mathematical model. Thank you so much for watching this video.